Damped trigonometric functions, graphs. Many applications in engineering use a damped function. A damped function often involves a sine or cosine with a damping factor represented by an exponential function or a polynomial. On the next slide is an example of a function you might see when studying a course such as circuits. You will see that the function oscillates until finally approaching zero. Now, does it ever really get to zero? Sure. Ultimately, at infinity, it would be at zero, but the oscillation. Okay, we're going to work with damping factors involving polynomials. Consider x sine of x. We'll start at x equal to 0, then see what happens as x increases. As x increases, the amplitude of the graph increases. Is there a way to graph this without plotting a lot of points? The period is 2 pi, and yes, there is. Since the period is 2 pi, we have a start on graphing it. We are damping it with x. Since x is a damping factor, sketch y equal x, y equal minus x from 0 to 8 pi. All right, you see where we've sketched it. We've gone from 0. Now, stop the video. Okay, now you've got your y equals x and minus x, so sketch the sine of x using its x-intercepts, max points, and min points. Stop the video and do these things that I've mentioned. Carefully connect the dots. Your graph should look like the one on the left. Notice what happens when the range is minus 8 pi to 8 pi. You notice it becomes symmetric. In the above case, the function was getting larger. Just for the sake of completion, what needs to be done to make it go to 0? Well, period is still 2 pi, and so we will use the function y equals 10 over x times the sine of x. Okay, to draw the curve by hand, then use the curves y equals 10 over x, y equals minus 10 over x to fix some boundaries. And you should get something that looks like the curve to the left.